Hi, this is Jay Clark. I'm a senior AI and ML solutions architect with AWS. In this video, I'm going to quickly take you through a tutorial using Amazon Rekognition. We're going to use it to train a baseline image classification model uh, for future work with other applications and services, notably SageMaker. Specifically, we're going to create a project and load a dataset into Rekognition. Then we're going to train a custom model and evaluate that model on a target dataset. The dataset I'm using is of blood cells or blood cell images, specifically white blood cell images. There are roughly 3,000 images for each of the four different cell types that we're working with, roughly split into granulo and agranulo-cytes, for those that know these things. It's available in Kaggle. Additionally, so the dataset that we're going to use are the images here. They're already split into train and test for us, and inside we have each of the four types or folders for each of the four types. We'll see some examples of these images later. Additionally, with this data set, it also provides bounding boxes in the annotations where the white blood cells are. Rekognition can handle classification as well as object detection, and so possibly in a future video, I'll put those two things together and show you a more complete solution or some of the more advanced features. But in this one, we'll just do image classification. So we'll download this. I've already done that and upload it to S3. I have also already done that, and I'll just show you where that is. In here. And in the blood cells folder, and you see the breakdown of train, test, and test simple is the same breakdown that we had here of test, test simple, and train. And it has the same subfolders as well, so each of our four classes, and we'll use this for our labels. But now we're all set to head to Rekognition. And we're going to use custom labels because we're going to fine tune a model. And if you click this side panel, we can then click projects. And if you haven't used Rekognition before, it'll ask you to set up an S3 bucket just to store all of your artifacts related to Rekognition. It gives you the name. You can just click create and it exists. Additionally, so we're going to create a project. As you see, I already have one here, but we can call this blood type, and I'll just add Rekognition there, and we can create this project. At this stage, there are 4 steps for us, but really we're going to use 3. We need to create our data set. So really this is just giving the location of our images in S3. Next, you would label if you needed to label, specifically if you needed to draw bounding boxes or add specific labels. We don't need to do that because we already have our labels, so we'll skip that step. Then we'll train our model and sort of leave it training. And then finally, we'll get some evaluation results. So let's load in a data set. We have 2 options of either letting Rekognition split our data for us, or if we have it already split, we can choose that option, and we will. We're then going to decide where we're importing images from. I'm going to import them from an S3 bucket. You can upload them from your computer as well, or load them in from somewhere else. And I need to get the location. So I just need the URI. So I'll go back to S3. And I place them in the studio bucket. Blood cells. This is for the training dataset. So we'll hit train. And I'm just going to copy the URI here. I can paste this. Okay, and so that looks good. Additionally, so there's an automatic labeling feature, which essentially is if we have them saved in separate buckets for their labels, we can just click that and it'll be labeled for us. So we won't have to go through the images and label them ourselves. Additionally, so if you'll notice, this bucket is one of the SageMaker buckets. If you're not using the Rekognition bucket, you just need to ensure that Rekognition has permissions for that bucket. And so that's what these policy updates are saying. And so what you would do is just take these statements, copy them, and then we're going to take them over and place them into the bucket. So there's a link here for paste this policy into the bucket policy. It'll take you to S3 and specifically that bucket and to the permissions tab. And if you scroll down, there's your bucket policy and you just want to edit that. So there will already be a statement here or a number of statements depending on what you've set up previously, and then you right below can then paste in your additional policy. I've already done that, so I don't need to sort of repaste these things, but you basically just click there, Control V, or right click and paste, and you're done. You can add additional policies if you like. We don't need to do that here. And then scrolling to the bottom, we just save changes. So now we have our permission set up. If we head back to Rekognition and just sort of scroll down, that's all we need to do for the training data set. We just need to also give it the location for the test data set. And it's also going to come from S3, and instead of it coming from train, it's going to come from test. And we can copy the URI here as well. Come back and paste. And we're going to do the same thing because we can automatically assign our labels. And we've already added our permissions for that bucket. And so we're okay. And now we can create our data sets. And this will take a few seconds. Okay, so that completed. Took, not even 30 seconds. So it was pretty quick, although I did still skip. As you'll see, now we have a training and test data set populated, roughly 10,000 training images, roughly 2,500 test images. And at this stage, right, so we can review our data set, we can add labels, label things. I'll just show you quickly what you have below, and then it's just showing you samples or all of the images that have been loaded in. If you click on labeled, so this would show you if there were images that weren't labeled or that it couldn't label, and it'll show you any errors. But additionally, we can now sort of look at specific classes. So if we want to look at the lymphocytes, we can see only those classes and what they look like. And this is really useful as a sort of sanity check or quality control check. You just want to make sure that what you're seeing here are lymphocytes, if that's what your labels are, and you can have multiple labels, and you can also see bounding boxes if you've added bounding box annotations as well. But given my familiarity with the subject, I'm going to say, yep, that looks like a perfect lymphocyte, and we can move on from there. So at this point, you can go to a number of places. You can also look at the test images. Really, we want to train a model so we can get a good baseline. And we can just click train model, and this will start running. Right, so to just give you notice, it can take 30 minutes or it can take up to 24 hours. This will take a couple hours, but certainly well within each of those bounds. And while it's doing that, it'll tell us training in progress, and we're free to go and grab a coffee, grab a lunch, anything along those lines. So I'll sort of take a few seconds here just to sort of mention the use cases for Rekognition, and really there are two that I use it for. The first is sort of the common. If you want to have a tool or service for adding image or video analysis to your application without necessarily expertise in image analysis, this is the tool for you, right? We just uploaded some images, we loaded these images into Rekognition, clicked train model, and we're training a model. The other use case, or the use case I find myself using this for more often, is as a baselining tool. So I'll receive new images, new data sets. I need to create a model that performs some task well. This is a great baseline because again, it's so simple. I just load the images, click train, and I'll see what sort of performance I can see out of the box. Right. So the couple of cases here. Let's say we'll get an F1 score. Let's say my F1 score is really high, 0.99, something along those lines, and that's within my tolerable range for whatever use case I have. Well, then I'm done, right? I spent an hour, I mean, much less than an hour, but spent a couple of minutes uploading this data set and just letting it train, not counting that time. And now I'm done, right? I can take this model and put it into production, and I haven't wasted my time sort of crafting this beautiful architecture that I didn't need. Additionally, or sort of counter to that, let's say I train this model and I get effectively random performance. That's also going to tell me something. There's a problem either with my labeling, with my data, or with the problem I'm trying to solve. And so that can also save me some trouble, right? So I'm taking, I guess, the model portion out of the equation, just saying how good is my data set, right? I really don't want to waste my time. And so this tool allows me to limit that waste. So I'll skip this ahead until we're done and see you there. And we're back. Okay, so I let this run overnight, although it didn't need it. And now below our blood type recognition project, we have our model, right? This model has the creation date and model performance. This is F1 score, but we'll see more in a couple of seconds. And it gives us the status, just that training's completed. If we were to deploy this, then we'd see a running status. But clicking on this, we can get a bit more about our evaluation results. So yeah, again, this is our F1 score, but we also get our precision and our recall, which are both pretty high. And this is really, at this point, you can determine how well this did given what your use case and goals are. So if 0.942 F1 is enough for you, then you are done, right? And we effectively just uploaded data and ran a training run. Additionally, you may need higher precision, higher recall, or you will have goals or thresholds related to that. But in addition to these overall things, these averages, we have the per label performance as well. So we have the F1 score for each of the classes, as well as precision recall and the assumed threshold. In this case, it looks like everything was well, except in the neutrophil case, that's below 0.9. That might take some more digging to sort of see what happened there. And yeah, if you look at the precision is what sort of caused that lower score. But at this stage, you now have a baseline. So whatever you do, or if you decide to try any additional models or architectures or data set transformations, you have your performance on this test set if you were to do nothing, which is really the use case that I like Rekognition for a lot. Additionally, so at this stage, there's a Use Models tab up here that we can look at. And this is if you want to effectively deploy your model or make essentially open your model so that you can get predictions from it. You can choose a number of inference units that will depend on the model and what throughput you need, the data and the throughput you need for that. But what's also really neat is they have API code for how you would use the model if you wanted to. So you can use it from the command line interface. If you're actually using this as a baseline, you might be using Python or some other language, and so it will show you the code for if you wanted to start the model, although you can start it from here, versus if you wanted to actually get a prediction for that model, right, which is here, which you effectively just give it a bucket and image, and you send it off. And then finally, if you want to stop the model, but again, you can also stop the model from this panel. So with this, we're effectively done. I do want to show one other thing, or one other use for Rekognition, and it's back in our evaluation tab. So in evaluation, when we look at our evaluation results, we can view the test results, which gives us a bit more detail. So now we can see, some of our mispredictions and see, what was missed, what it thought it was, and what it actually was. And this is useful because again, in our baselining use case, now I know, this was incorrectly classified. So this image I can sort of hold out as one of the tougher examples, or one of the examples I want to make sure I get, and I can analyze why it may have missed that, right? So in this case, it may just be that there wasn't enough of the image to sort of determine what it was, right? Which is important to know versus having the model see clear examples of a cell and be unable, right? It's a lot of these seem to be really on the edge. Depending, but yeah, these really seem to be close to the edge of the image, and could be one of the reasons why we're getting some mispredictions there. But that's something you wouldn't know unless you were able to look at some of these missed examples. And so that is something that you should definitely make, that I definitely make use of. So with all of that, I think I will wrap it up there. The links to any of the material used here it will always be in the description. If you have any questions or comments, please leave them below. We always check those, and I hope to see you again. Thanks.